Hey folks, how we doing? Mr. Carter here, ready to teach math lesson 211, classifying quadrilaterals. So our learning target today is this. I understand how to classify quadrilaterals. Now quad, you see the prefix quad there means four, so shapes with four sides, by their properties. Okay, so we're going to talk about that today. Our math message: draw two four-sided polygons, one with four right angles and one with at least one acute angle. So here's our math message again. So I'm going to draw a four-sided polygon here with four right angles. And as you know, a right angle is like a perfect corner, that perfect square. And I'm showing there with a square on the corner, and that's how you show a 90-degree or right angle. So that's one right angle. So here's a second one, here's a third one, and a fourth right angle. Now here's another four-sided polygon, but this time we want at least one acute angle. So acute, if you remember, is an angle that's less than 90 degrees. So we have one acute angle here, because if you were to measure it, it would be less than 90 degrees. And if I was to go take my arrow and go like this, that would be the perfect L here. But you can see it's less than that. And here, this shape happens to have another acute angle on that side. Okay, now here's a question for you. What are some attributes that are the same for each of these quadrilaterals, and what are some that are different? So I'm going to make a little T-chart here, or table, and I'm going to talk about some attributes or qualities that are the same for this four-sided shape here and this four-sided shape. Well, first of all, they all have four sides, and here we go. So one side, two, three, four sides there, and one, two, three, four sides there. Next, they all have four angles, and again, in the blue shape, has four right angles. That's one angle there, second angle, third angle, fourth angle. This, the green shape has also four angles here. So we have an angle there, an angle here, an angle there, and an angle there. So again, that's something they have in common. They both have four angles. Something they all have in common too is that the sides can either be the same length or different length. We didn't talk about the lengths of the sides. Now, if I'm eyeballing it, this one here, I could tell that the top, this side here is a little bit longer than this side. So I would classify that as a rectangle. But I could have made it all four sides the same, and that would have been a square. Now down here, again, if I'm eyeballing it, this top side here is a little bit longer than that. I could take a ruler and actually measure those, but that's not what we're doing today. So again, we could have made the sides the same length or different lengths. Now, another thing that makes them the same, these two shapes the same, is that the opposite sides are parallel. So parallel is when sides don't intersect. So if I'm looking at our rectangle here, these are opposite sides where the arrows are pointing, and they are parallel. So if I was to continue these lines forever and ever and ever, they would never intersect. Same thing with these sides. These are opposite sides, this side and this side. And again, if I was to extend the line on both sides, they would never intersect. Same here with our green shape, which, by the way, is a parallelogram. If these are opposite sides, if we were to extend them, they would never intersect. And again, these opposite sides are also parallel. Now, what makes them different? Well, one has four right angles, and the other one has a mix of acute and obtuse angles. So like, again, if I look at our rectangle, the blue shape, those are right angles. However, if I look at the green shape, these are not right angles. The ones I'm pointing to right now are obtuse. They're larger than 90 degrees. These ones are acute. So it has a mix of acute and obtuse angles. Now the sides may or may not be perpendicular. So that makes them different. So what is perpendicular? So these sides here, these adjacent sides, the sides that are close to each other, that are next to each other, they are perpendicular, which means they meet at that 90-degree angle. Okay, whereas, and that's the 90-degree angle that they meet at. Whereas this shape, the parallelogram, these sides are not perpendicular. So that makes these two shapes different. Okay, So for the next part of this activity, you're going to need to be looking at these shapes here. You may have a sheet that you can cut out and manipulate the squares, and you may not, and that's okay. If you don't, you can just listen to the video and take a look at how I move around the shapes. But if you do have this sheet, you're going to want to cut out all these shapes so that you can move them around. Now you're going to need to take your shapes and put them into groups with matching attributes. Okay, so matching qualities, for example. So I'm going to have you pause the video, take a minute, and just play around with the shapes and kind of put them into groups with things that may be the same. For example, they may have parallel sides, or maybe they have sides that are equal length. So go ahead, play around with these shapes and put them into different groups according to their attributes. So take a minute to pause the video to do that. Okay, so now I am going to group my shapes, and I'm going to ask to see if you can you figure out what the common attributes are. So here we go. So I'm going to take shape A, put it in group 1. A, group 1. B, group 1. H in group 1. E, D, I'm going to throw that in group 1 also. A lot of things going into group 1. O, I'm going to put O in group 1. P, I'm going to put in group 1. And there you go. Okay, now I'm starting to put things in group 2. So I'm going to put F in group 2. J in group 2 as well. I in group 2. Let's throw L in group 2 also. Are we seeing some patterns? Okay, so now I've got G. I'm going to put G in group 3. And M also in group 3. And finally C in group 3. All right, so take a look at these shapes. See if you can figure out how I group them. Aha! In group 1, there are no right angles at all in any of these shapes. In group 2, these shapes all have 4 right angles. See, 1, 2, 3, 4, and you could tell they're right angles because of the squares in the corner. All these shapes have 4 right angles. And check out group 3. They have exactly 2 right angles. See, there's a right angle here and here, so that makes it 2. Again, 2 right angles, and then 2 right angles here. All right, so now what I want you to do is go to Math Journal page 59. Okay, so again, you're going to need to take your shapes and put them into matching attributes. So again, we're doing this again, but this time I'm going to start you off. So I want you to put, look at shape A, that goes in group 1. Shape H goes in group 2, and shape E goes in group 3. Okay, so again, I'm going to start placing these shapes according to their attributes, and I'm going to see if you can figure out what the attribute is. Okay, oh, where did my thing go? Okay, so here we go again. So A is in group 1, H is in group 2, 3, E is in group 3. Here we go. All right, so I'm going to put F in group 1, L in group 1, J in group 1, I in group 1. You seeing anything here? O is also going in group 1, and K all both in group 1. Okay, so now I'm working on group 2. So I'm going to throw D in group 2, M in group 2, E in group 2, G in group 3. Sorry, these are all in group 3, my bad. C, P in group 3, and finally C in group 3. Okay, so take a minute. I want you to pause. Can you guess the common attribute? So pause the video, take a good look at how I place these. Okay, welcome back. So if you can't figure it out, I'm going to give you a hint. Parallel sides. What does that mean, parallel sides? Well, take a good look at the shapes in group 1 and think about their parallel sides. Take a look at group 2 and think about parallel sides there. And finally, group 3. All right, here we go. Group 1 has 2 sets of parallel sides. See, we have one set here. these opposite sides are parallel, and the second set is these sides here. These sides are parallel. Every one of these shapes has two sets of parallel sides. Take a look at that. So this is a set of parallel sides, so that side and that side are parallel, and the second set is this side and that side. So look at group 2. There in group 2, the shapes only have one set of parallel sides. Look at H. This side and that side are parallel, so that's only one set, whereas this side and that side will eventually intersect somewhere up here. Same with D and M, only one set of parallel sides. And if you can look at 3, you probably figured it out already. There are no parallel sides in any of these shapes. At some point, both opposite sides will intersect. So, what does that mean for you in page, I think it's 59? Well, here we go. Write the letters of the quadrilaterals that go in each group. So group 1, all these shapes belong into group 1. H, D, and M belong in group 2, and E, B, C, G, P belong in group 3. And here is the answers. So all the quadrilaterals in group 1 have this property in common. They all have two pairs of parallel sides, and we talked about this already. Group 2 have one pair of parallel sides, and group 3 have no parallel sides. So take a minute, pause the video if you need to, and fill in your answers here for your math journal page. Okay, moving forward. So question 2 on your math journal page, it says, in which of your groups does quadrilateral X belong? Explain. Well, it belongs in group 2, and that's because quadrilateral X, though this quadrilateral, has one pair of parallel sides, like all the other quadrilaterals in group 2. And here are your parallel sides. This side and that side are parallel, so that's one set of parallel sides. These sides here, again, will eventually intersect. So that's not a parallel side. Okay, so there we go. Now, a trapezoid has at least one set of parallel sides. So which quadrilaterals here out of these groups here would be considered trapezoids? Well, that would be group 1 and group 2, because again, in group 1, they have, these are all trapezoids. So all these shapes here are trapezoids because in group 1 have two pairs of parallel sides, and group 2 has one pair of parallel sides. So again, their definition of a trapezoid is that they need to have at least one set of parallel sides. So that excludes group 3 because they don't have any parallel sides at all. So these two groups here are all trapezoids. Okay, so a parallelogram now is a quadrilateral that has two pairs of parallel sides. So what group do you think that is? So which quadrilateral would be considered parallelograms? Well, that would be group 1 because it has to have two pairs of parallel sides. So the only group that has one set of parallel sides, two pairs of parallel sides is your group 1. So these shapes here, A, F, I, G, J, K, L, and O, are all parallelograms. None of these are, the rest of these are not parallelograms. Okay, so let's look at these shapes again. So now we have another shape I want to talk about. It's a kite. A kite is a quadrilateral that has two separate adjacent pairs of equal length sides. So adjacent are two sides that have one endpoint in common. That's the definition of adjacent. So let's talk about which shapes would be a kite. So again, equal length. So they have to have equal length sides. So E would be a kite because all these sides are equal. So again, if I took a ruler and measured them, they would all be the same size. So it's weird. It doesn't look like a kite, but technically it is because these two are adjacent sides. And if I was to measure that one and this one, they would be equal lengths, along with this one would be the same length as that. So it fits the definition of a kite. F is a kite because look, 1, 2, these sides are all the same. J, we have that side is equal to that side. I'm sorry, G, and then this side is also equal to that side, so that makes it a kite. I, that side, is equal to that side, and this side is equal to that side. So the I is also a kite. K is a kite because that side is equal to that side, and this side equal to that side. N, that side is equal to that side. That side is equal to that side. And lastly, O, oh wait, sorry, not O, not lastly, but O, these sides are equal, those sides are equal, and then finally P, that side is equal to that side, and these sides are equal. Okay, so again, it has to have two sides that are next to each other that are equal in order for it to be a kite. A rhombus now is a quadrilateral with four sides that are all the same length. So not just the ones that are close to each other, but all four have to be the same length, okay? So F, all four sides are the same length here. Not just the, like if I was to look at E again, that's a kite but this side is not the same length, so it would not be a rhombus. In order for it to be a rhombus, all four sides need to be the same length. So that brings us to I. All four of those sides are the same length. K, if I was to measure that, those would be the same length. N is also a rhombus, and also O is a rhombus. Now, a square, however, also we know what squares are. Squares are also the same length, but here's the kicker with squares. They have to have all four right angles. See? And four right angles. So we're going to be eliminating a bunch of these rhombuses here. And here we go. So maybe not. Okay, so we're going to eliminate K, we're going to eliminate N, and we're going to eliminate O. So that leaves us with F and I. These are the only two squares because, again, it has to have four sides that are the same and four right angles. Here we go. That moment you realize SpongeBob SquarePants aren't actually square. See, look, not square. Haha, just a little break. All right, anyway. A rectangle now is another shape I want to talk about. It's a quadrilateral that has four right angles. That's the only quality that makes it a rectangle. So anytime you see four right angles, it's going to be a rectangle no matter what the length of the sides are. So that's F, I, J, L. Those are the only shapes that have four right angles. And again, it doesn't matter the length. As long as it has four right angles, it's considered a rectangle. All right, so now some quadrilaterals have more than one name. So like take F, for example. It can be a square. It's a rectangle. It's a rhombus. It's a parallelogram. It's a trapezoid, believe it or not, and a kite. So yeah, it can be all of these things. So some shapes, depending on their attributes, can have more than one name. All right, here we go. I did your journal page with you, so that's all done. But now you have your home link to do. And I hope this was helpful, and take care. All right.